In this video, we're going to solve an optimization problem using trigonometric functions. So here's the problem. A trapezoidal gutter is to be made from a strip of metal 22 inches wide by bending up the edges. If the base is 14 inches wide, what width across the top gives the greatest carrying capacity? Now, this problem can be solved without the use of trigonometric functions. In other words, we can solve this problem just by using algebraic expressions or algebraic functions. However, for instance, you're trying to solve an optimization problem. So you provide a given, you sketch, and while you are sketching, you can see that an angle measurement is involved. Therefore, you have the option to use trigonometric functions and see if it works. Sometimes the use of trigonometric functions would prove to be a more convenient approach or an easier approach. However, sometimes it will complicate your solution. Regardless, you can treat this as an option when dealing with optimization and even related rates problems. Okay, so we have here, we start with a strip of metal. Let's say, imagine this is the strip of metal. So we are looking now at the cross section of the strip of metal. Imagine it's a very thin plate and we want to make a trapezoidal gutter. And in order to do that, we need to bend up the edges at a certain angle. Okay, so there's the keyword. We have an angle measurement. Therefore, we can use trigonometric functions. So again, uh, we need to bend up the edges, okay, at a certain angle to create a trapezoidal gutter. It will look something like this. The base is 14 inches. Okay, then remember that the total length of the metal strip is 22 inches. Okay, therefore each of the edges or each of the portions here is measured to be 22 minus 14, that would be 8, and then divided by 2, so 4 inches. Okay, and then we are asked to find uh, the width across the top. So this one, let's call this A, for example. That will give the greatest carrying capacity. This means that we need to maximize this area here, okay, to maximize the capacity of the trapezoidal gutter. Okay, now we can divide this area into 3 parts. Okay, so we have a triangle portion here, a rectangle, and then another triangle, which is equal to the area here, right? So we can call this area 1. Then let's call this area 2, which is also equal to the area of this portion here. So let's call this area 2 also. Okay. Now, if you can notice, there are actually right triangles on both sides of the gutter, right? So let's just look at one of them. Let's say this one. So let's form a right triangle here. Let's just focus on this right triangle first. So let's call this side X. For now, we don't know this side, also this side, so let's call it Y, for instance. The hypotenuse is measured to be 4 inches, remember? Okay, and then let's call this angle here angle theta. Okay, Now, if this is x here, the base of the right triangle, so this is x. Therefore, at the top, this is also x, right? And so is this portion here. It's x. And then this portion is equal to the length of the base, right? So 14 inches. Okay? So now we can set up the formula for A, right? A in this case is x plus 14 plus x. So that would be 14 plus 2x. Remember that we want the greatest carrying capacity, and this means we need to maximize this area here, the area of this trapezoid. Therefore, the formula for finding the area of this trapezoid is our primary equation. Okay, so we still need to set up the area of this trapezoid. So total area of the trapezoid is equal to A1. A1 is the area of this rectangle here, plus the area of the triangles. Since these two triangles are the same or equal in area, then we can just put twice area 2. Okay, where A1 is again the area of this rectangle here. So we have 14 times the length of this side, and the length of this side from the right triangle is y, right? If this is y, then this is also y, right? So we have 14 times y for area 1, plus 2 times the area of A2. A2 is a triangle, so 1/2 base times height. So 1/2. The base is x, and then the height is y. So xy. Okay. Simplifying, we get 14y plus xy. Okay. Now here's where we can choose whether we continue with the algebraic functions approach or we use trigonometric functions. If you opt to continue the algebraic functions approach, then you can uh, express y here in terms of x using the Pythagorean theorem based on this right triangle here. Okay, then differentiate with respect to x, equate to 0, solve for x, and then plug in the value of x in this equation to get a. Okay, but again, for this discussion, we will be using trigonometric functions. So let's try to express everything in terms of trigonometric functions. Okay, so let's go back to this right triangle here and let us formulate some trigonometric functions of angle theta here. So we have theta, adjacent angle theta is x, opposite angle theta is y, hypotenuse is 4. So let's define x and y in terms of trigonometric functions. So first for x, since it is the adjacent side relative to theta, then we can use cosine, right? So cosine of angle theta here equals the adjacent side, which is x, divided by the hypotenuse, which is 4. Okay, so solving for x or isolating x, we get 4 cosine of theta. For y, y is opposite angle theta, so we should use sine theta. We have here sine theta is opposite, opposite is y, over the hypotenuse, which is 4. Therefore, y is 4 sine theta. Okay. Now what we need to do is just plug in these equivalent expressions for x and y into our equation for a and the area. Again, a denotes the width across the top of the trapezoidal gutter. So we have a equals 14 plus 2 times x, where x is 4 cosine theta. So a equals 14 plus 8 cosine theta, right? And then for the total area, so we have here a equals 14y, where y is 4 sine theta, plus x, where x is 4 cosine theta, and then times y, where y is 4 sine theta. Okay, so simplifying, we get 14 times 4, that would be 56 sine theta, plus we have here 16 cosine theta sine theta. And let's not forget that we are required to find a, right? So you can find a using this equation. Okay, so these are the equations that we formulated earlier, right? This is the primary equation. This is the equation that we need to differentiate. And before we differentiate, we can actually convert this product cosine theta sine theta into its double angle identity of sine, or we can proceed with differentiation and then apply appropriate identities later on. So let's just differentiate first with respect to theta. So we have here d theta equals 56 times the derivative of sine theta with respect to theta. That would be cosine theta plus 16. So we have here product of cosine and sine. We need to apply product rule, right? So we have cosine theta times the derivative of sine theta, which is cosine theta, plus copy sine theta, and then times the derivative of cosine theta with respect to theta, and that is negative sine theta. Okay, so let's just simplify. We have 56 cosine theta plus 16 cosine squared theta. This would be minus sine squared theta. Okay, equate this to 0 to get the critical value of theta. What we have here is a trigonometric equation, and to solve trigonometric equations, we can try to express everything in terms of a single trigo function. Let's say we express everything in terms of either cosine or sine. Okay, but in this case, it would be more convenient if we choose cosine. Okay, so we'll see later on. And number two, we need to express everything in terms of a single argument. Okay, so we have here theta, theta, and then theta, so there's no problem. Okay, now how do we express everything in terms of a single trigo function? We can apply identities, right? So if you look at this expression here, if you can recognize this, this is actually the double angle identity of cosine, right? So cosine 2 theta equals cosine squared theta minus sine squared theta, which is also equal to 1 minus 2 sine squared theta, and lastly 2 cosine squared theta minus 1. Okay, so we have um, three options. We can either convert this to this expression, or this expression, or this expression. Okay, so remember, just remember that we need to express everything in terms of a single trigo function and a single argument. If we use cosine 2 theta, then we'll have two different arguments, theta and 2 theta. Okay, so this is eliminated. If we use this expression, then we have two trigo functions, cosine and sine. Therefore, we have to use the third identity. Okay, So single trigo function, cosine and cosine, and then single argument, theta and theta. Okay, so we have here 0 equals 56 cosine theta plus 16 times 2 cosine squared theta minus 1. Okay, now these three identities here are derived from Pythagorean identity. Okay, so another way actually is that we can convert sine here using Pythagorean identity to cosine. So sine squared theta is equal to 1 minus cosine squared theta, and it will result to this identity. Okay, so that's what we are using here. So now we have 0 equals 56 cosine theta plus this is 32 cosine squared theta minus 16. And then if you look at the three terms, the GCF is 8, so we can divide both sides by 8. 56 divided by 8 is 7 cosine theta plus 32 divided by 8. That would be 4 cosine squared theta minus 16 divided by 8 is 2. Okay, then we can rearrange so that we can see that it takes the form of a quadratic equation, right? If we let, for example, cosine theta be x, so that you get 0 equals 4x squared plus 7x minus 2. Factoring, we get this is 4x minus 1 times x plus 2, right? So we have two solutions. 4x minus 1 equals 0 and x plus 2 equals 0, where x is cosine theta. So 4 cosine theta minus 1 equals 0, then cosine theta plus 2 equals 0. Okay, so from the first solution, we can get cosine theta equals transpose -1, so it will become +1 on the right hand side of the equation, and then divide both sides by 4, so we get 1/4. Then the other solution, cosine theta equals -2. If you look at the equation for A, we can actually directly plug in the value for cosine theta so that we can solve for A. However, we have two solutions. Now, if we plug in -2, we'll get a negative answer, and that's not what we want, right? And it also makes sense because -2 is not part of the range of cosine function. Okay, so cosine of any angle ranges from -1 to +1. Okay, so this is extraneous. It does not make sense for the problem. Therefore, we only want this value for cosine theta. So plug in this value to this equation. 14 plus 8 cosine theta is 1/4. So A equals, A divided by 4 is 2. 2 plus 14 is 16. Okay, therefore A is 16 and the unit is inches. This is now the width across the top of the trapezoidal gutter that will give the greatest carrying capacity.